Hi folks, this is Nikhil and you are learning GoLang with me. In this session, I'm going to talk about the advanced concepts in concurrency in GoLang. So let's get started. So we have already seen the different concepts, the basic concept, the foundation of concurrency in GoLang. And just to revise the stuff, we have seen the channels, we have seen the coroutines, we have seen how you can join the two different coroutines, something similar to the cyclic latch in Java. Then we have also discussed about the send only channel, the receive only channel, the duplex channel, or let's say the bidirectional channel or single directional channel or unidirectional channel. And then I also discussed about how the GoLang figures out what kind of architecture your server has or what kind of OS the server is running, or the different parameters that are essential part of the concurrency paradigm. Now in this particular session I will be focusing on how to use multi-channels so that you can exploit the capabilities of processor to the extreme. So imagine you have the server and then you are running your program, and let's say you want to calculate the multiple processes. Let's say you have some kind of vectorized operation, and you have multiplication of the vectors or multiplication of the matrices. So most probably what you'll be doing is you'll be distributing that particular operation into a chunk. Different chunks will be handled by the different processors. I'm talking about a single server. I'm not talking about a server farm in which you could have the Spark, Apache Spark running behind the scenes, and then the task is getting distributed across the entire cluster. I'm not talking about that. It's kind of let's say pandas in Python, in which you have let's say numpy array, and then you are doing some kind of array operation. So you would like to exploit your processors to the extreme, and that's why over here we will be imitating the similar behavior by making use of coroutines and channels in GoLang. So let's see the example. So the example is to multiply the numbers. You can do multiplication or addition unless or until the operation is associative and cumulative. So now let's say over here I have a few numbers to multiply, and then I'm actually multiplying them. So first thing is you would like to get those numbers on some buffer, and then you will be distributing those numbers, and then the multiplication will be carried out. Now over here what I've done is I have created two coroutines. One coroutine is to get the numbers. Get the numbers for operation, for get the number, that's it. So what I'm doing is I'm iterating over a counter. Now this counter goes from 1 to 5. I'm loading my channel, or I'm uploading the integers to the channel, and then I'm closing that particular channel, and this is happening in one of the coroutine. So now at one time you have main, and then one coroutine is pushing the numbers, and then there is other coroutine which is actually listening to the channel and then waiting for the numbers to get loaded. And once the numbers are loaded and the channel is closed, then automatically the other part, that is the consumer, gets into the position and then gets the numbers by iterating over the channel, and then calculate the multiplication of the numbers. So these two coroutines are actually getting executed in parallel, and there is a third coroutine which is the main, and it is blocked because of the fact that I'm using this display line, which actually gets blocked because I am actually waiting for some input from the channel out. This out is coming from the multiply app function, and then this function is blocked because of the fact that it is iterating over the channel. So unless and until my channel is filled up with the numbers and it is closed, this line will be blocked, and then whenever the channel is filled up with the numbers, then only the range will start working, and then you calculate the result, you push the result onto another channel, and then you close that channel, and then finally you use that channel to retrieve the result in the main function. So now you can substitute these go routines by anything. You can see that I can call get the numbers as many times as I want. I can have, let's say, depending upon my processors, if it is dual core, quad core, or more than that, if I have 16 cores, then what I can do is I can create those many go routines. I can calculate the or I can take the numbers in parallel, and then in the another part I can have the similar set of the go routines. Now over here, instead of accepting the numbers, those go routines can calculate the operation of multiplication over the numbers. So now you can see the power of the concurrency and the parallelism over here, because I'm trying to exploit, I'm trying to leverage the processors that are available under my kitty. So let's execute this program and let's see the operation. So you can see that the output of the multiply operation is 120. So if I increase the numbers, then you will see that it is 362880. Now I can execute the operation, similar operation, with the help of the single thread. So I don't have to use go routine, I don't have to make use of the channels. What I just need to do is get the numbers and then multiply, just use the single thread. But because I have 8 processors on my server, I would like to use them. I don't want to have the CPU idle, so that's why you make use of the go routines and the channels, so that you can leverage the infrastructure, the resources that you have. Now you have to remember the fact that it is not the distributed system I am referring to, it is the single system I am referring to, but that single system has multiple cores, and then you can make use of them to perform the vectorized operation. So for example, over here, let's say instead of the get routines, what I can have is I can have the by the way, just to have the best practices. So now over here, in the get numbers, we are using the send only channel. In multiply app, we are using the receive only channel. So it's best practice to actually use the channels in the respective fashion. For example, what I will be doing is, because this is a receive only channel, I will be actually using the receive only indicator. So for example, this one, so now the in becomes my receive only channel. Now I will have to accept that. So this is my receive only channel, I cannot send anything to this. So here also I will have to do the same. Now this matches, and then over here my in is so I'm sending the in as the receive only, and similarly for out also over here it is the receive only channel. So that's why you just have to receive the numbers. If you want to restrict the user not to use this channel to send the numbers, then what you will be doing is, again you will be using the same indicator to make this channel receive only. So now out is receive only. So if, let's say, if I have something like this, I will not be able to do so, because of the reason that this is a receive only type. You already seen that, but then it's better to use the best practices even in other examples, not specifically to that example. Now what I can do more is I can have, let's say, the multiple channels So over here what we'll be doing is, let's say I want to have this for 5 times. So let's say this is counter 0, counter less than 5, and counter plus plus. So as I said, you could have the multiple multiplication operations happening on the fly. So what you'll be doing now is this one. Let's also see the number of coroutines at any point of time. So if I add the delay, then you will see that I have multiple coroutines. So let's say over here add the time dot sleep, let's say 1000. Now you can see that now once I have the adequate sleep time, then you can see that my number of coroutines is 2. So let's say if I increase the number, then also you can see that now my coroutines are getting incremented. So as I add the more computation work, you will be seeing the more coroutines. See, now I have 3 coroutines. Now this is happening at the same time. So 3 coroutines means 3 cores, 3 CPUs are actually executing my program in parallel. So if I add more, then you will see the more in place. So let's say if I change it to addition, then I will not encounter with the overflow exception of for int, and now you are supposed to see the higher number of coroutines. Let's see. It's also good thing to actually execute this into the particular coroutine, because our main coroutine is blocked. So that is the reason because of which we are not able to see the multiple number of coroutines. Now over here you can see that 3 is the prominent one. Now if I change it to multiplication, Let's see what happens. And if I don't stop for the operation, this operation, then you can see that I have many go routines because of the fact that I was waiting for the out. So this is also fan in fan out pattern which I'll be demonstrating later on. That's it for now. See you in the next session.